Alright, and welcome to Algebraic Transformations, Level 2. Now, in number 1, it says the function f of x equals 2 parentheses x plus 6 squared minus 3 is changed to g of x equals 5 f of x. Part A says describe the transformation. Well, I know that my value that is in front of the f of x term is actually my a value, because we always write in the formula a f of x. So I know that my a value is equal to 5. Now remember, we are always comparing our a value to the value of 1. So you ask yourself, is 5 greater than 1 or less than 1? And since 5 is greater than 1, or aka a is greater than 1, we know that we have a vertical stretch. Okay, now part B says write out the new function g of x. And so this is where it gets a little bit tricky. So let's do this. Let's write first f of x in blue. F of x is equal to 2 parentheses x plus 6 squared minus 3. And then in red, I'm going to write the rule g of x is equal to 5 f of x. And remember, I'll call this my rule whenever we're writing g of x in terms of f of x, the other function. This is the rule that transforms f to g. And then from here, let's go ahead and put g of x in just a slightly different color. Okay, so here's going to be our new function g of x. And what I'll do is I'll keep all the elements of, here. And so what our rule is telling us is that we're actually doing 5 times f of x. So I'm going to put 5 big parentheses, and then what I'll do is I'll take the original f of x value and I'll write it inside that parentheses. 2 parentheses x plus 6 squared minus 3. So this is essentially what this rule is doing whenever we're changing the a value of the rule. We're multiplying the entire function by the a value, in this case 5. Now this distributes to our very first coefficient, that 2, and the 5 distributes all the way to the very end to the constant. Whatever's on the inside of the function, that is left untouched. So we'd write our new function as such. G of x is equal to 5 times 2, which must be 10. And then let's keep the parts that are unchanged from f of x still in blue. So we have the x plus 6 squared. And then, once again, this 5 times negative 3 is negative 15. And so our new function g of x is equal to 10 parentheses x plus 6 squared minus 15. Okay, let's move on to a second example. Okay, for our second example, I chose problem number 3 from the assignment, and it says the function f of x is equal to negative 6 square roots of x minus 5 plus 6 is changed to k of x is equal to 3 times f of x. So, similar to our last problem, we're only changing the a value, which is being multiplied by f of x, and kind of along the same lines, we say, hey, is 3, since a is equal to 3, how does 3 compare to the value of 1? And since 3 is greater than 1, once again, we have a vertical stretch. Okay, now part B says write out the new function k of x. So once again, let's write f of x in blue. Let's write our rule in red. In this case, it's not g of x, it is k of x is equal to 3 f of x. And from here, this is what k of x is going to look like once we apply our rule. We'll say, okay, from the rule itself, we have this a value of 3, which is then being multiplied by this entire function f of x. So I just take f of x and write it in place. Negative 6 square roots of x minus 5 plus 6. And from here we ask ourselves, well, how does the a value affect that function f of x? Well, we know it distributes to the first coefficient, the a value, and 3 times negative 6 is negative 18. And the one part that it won't change is always going to be the function, or the inside of the function itself. So the square root of x minus 5 is untouched. And then from here we have the 3 times the constant at the very end. This is the part that most students will make a mistake on. 3 times 6 is positive 18. And there you go. There's our new function, k of x. Now I encourage you to stick around because I'm going to show you what this looks like with the rational function. And you might make a mistake if you don't watch this one, just because this one looks a little bit different. Okay, for our third and final example, I'm using problem number 5, and this is what we call a rational function whenever you see a fraction inside the function. Okay, so the function f of x is changed to p of x, and the first thing we want to do is describe the transformation. Well, remember, this negative is purely on its own. Whenever our a value is negative, a negative a value, it means one thing and one thing only, that our function was in fact reflected. That's it. That's the only thing. So once I write the word reflected, I take a look at the 1/2 and I just look at the value of 1/2 completely separate from the negative. Okay? I never put the negative with a value when determining if the graph is vertically stretched or compressed. Now you ask yourself, well, how does a compare to 1 in this case? Well, 1/2 we would say is less than 1, and so we'd say that for part A, we know that we have a vertical compression. Whenever our a value is less than 1, we have a vertical compression. Okay, so it's reflected and vertically compressed. Okay, for part B here, let's go ahead and write our function f of x is equal to 8 over x plus 8 plus 3. And one thing to note is that the number on top, that is actually going to be our coefficient a. Okay, so I begin to write our rule. G of x is equal to negative 1 over 2 f of x. And then from here, let's go ahead and write out our new function. Oh, I'm so sorry. It's not g of x at all. Aha, good thing we caught that. This is actually p of x. Okay, so our new function, p of x, let's see here, is equal to, our a value is negative 1 over 2, so we're in fact multiplying everything in f of x by negative 1/2. And so I have my 8 over x plus 8 plus 3. And when writing our p of x value, the one thing you want to note, the reason a rational function is so different is that the number that we multiply is that a value on top. So we'll do negative 1/2 times 8. Now over here to the side, let's write negative 1/2 times 8. We can turn 8 into a fraction, 8 over 1. And top times top, negative 1 times 8 is negative 8 over 2 times 1, 2. Well, that's negative 4. So I have negative 4. And remember, the quote-unquote inside of the function never changes. So we have x plus 8. And then negative 1/2 times 3, we can do that math over here, times 3 over 1, if you will. Negative 1 times 3 is negative 3 over 2 times 1 is 2. And we just write minus 3 over 2. And there is our new function p of x. I hope that these have helped you out, and I'll catch you in our level 3 video.